In this unit, we're going to learn quite a number of theories to prove that two triangles are congruent. And one of the first theories is what we call ASA, and A stands for angle and S stands for side. So first of all, just a quick note. Remember postulate? Postulate is just a statement, which means it's just a commonly acknowledged statement. In this ASA statement, it says that if I have two triangles, if angle A and angle D are congruent, and then angle C and angle F are congruent, and on top of that, my AC and my side DF are congruent. So I've got one side, a pair of a pair of yellow angles and a pair of red angles are congruent. I've got ASA. Notice that this S has to be sandwiched between two angles. So it goes angle A, AC, and then angle C. If this side is AB, it's not going to work because that's not sandwiched between two angles. Okay? So it has to be sandwiched. So in what this postulate says, like I said, angle A and angle D are congruent. AC and DF are congruent. Angle C and angle F are congruent. Therefore, I can draw the conclusion that two triangles ABC and triangle DEF are also congruent. That's a D. Triangle DEF is congruent. Again, notice that A is matching D. And B is matching, angle B and angle E are matching. And then angle C and angle F matches. So it has to be in that order, that yellow, green, red order. If I rewrite this triangle on the left, if I rewrite it as triangle CAB with my congruent statement, I have to change the order here as well. I have to do FDE. All the corresponding parts have to match. So let's do this follow-up. In this triangle, let's complete the table. It says angle T and angle G. Which side is between this angle T and this angle G? What's the included side? The included side would be TG, right? What about angle G and angle L? The included side would be GL. Okay, finish the third one on your own. And let's see, draw angle ABC in the space below. So if I draw any triangle, I can draw this triangle ABC. Angle A and angle B is here. The non-included sides, angle A and B, the included side is AB. The non-included side would be AC and BC because I'm talking about angle A and angle B. The sandwich side is this side. The other two is not part of the sandwich. For angle B and C, the non-included side would be AB and AC. And you finish the last one here. So let's determine when to use ASA. Based on this diagram, can you use ASA congruence postulate to show the triangles are congruent? And explain. So first of all, I have triangle ABC, and another triangle is, let's see, for now I'm going to write BCD, okay? And notice that my angle ACB is congruent to angle CBD. So this and this is congruent. And then because they share this side, I can say BC is congruent to BC, reflective property, right? Whatever you see in the mirror is yourself. It's reflective. And then another given information is angle ABC is congruent to, this one has two lines, BCD. So yes, these two triangles are congruent, but be careful which one. Since I started with this one, I'm going to go, what's not mentioned is this one, angle A and angle D, right? So I have to write the triangle A. I go 3, BC, A, BC. Is congruent, is, see I have 3 ticks here. I go with this, D, and then I went to 2. So this side I have to go to 2, 3, 2, 1. So D, C, B, D, C, B. In other words, my angle A and angle D is matching angle, and my angle C and angle B, my C and B are matching in that way, right? So that's the first one. Oops. The second one, let's see. I have these two triangles. I have angle R is congruent to angle Y. Then I have angle S is congruent, I'm sorry, I didn't write the weekly well enough. Congruent to angle X. I also have a side, but notice that RT is congruent to ZY, but they are not included sides, meaning they're not sandwiched between the two angles. Therefore, no. These two triangles, I don't have enough information. Oops, sorry about that. Not enough information to conclude that they are congruent triangles. Here's another theorem. This one is AAS. Let's see. It says that if I have angle A, notice that it's just one marker, and angle D are congruent. I have angle C, 2 marks, and angle F are congruent. Then I had a third line, BC and BF. I can therefore draw the conclusion that triangle ABC is congruent to triangle, careful, I went from one marker to no to 2. One marker to no to 2. So it should be D, E, F. It's not always sequential like this, but be very careful with this. Okay? Let's look at this example. So let me go back. So again, this is called AAS. So in other words, in any triangle, as long as you have two angles and a side, whether it's ASA, meaning they're included or sandwiched in between, it's fine, or they're not included, the side is on the side, not included between, not sandwiched between two angles, that's fine too. So let's see, what additional congruence is needed to show these two angles are congruent by the AAS congruent theorem? So I know that I have one set, I call this angle angle 1 and angle 2. Angle 1 and angle 2 are congruent, and that's because they are vertical angles. So I can say I use vertical angle theorems to determine they are congruent. I also know that KL, which is this leg, and this leg, LM, are congruent because that's given, right? That's given. So I only have these two information. If I want AAS, I have to know that this angle J has to be congruent with angle and in order for these two triangles to be congruent by AAS. Now notice that I have to do J and N. I cannot do K, because if I do K, I have an ASA scenario. I don't have AAS scenario. Okay, so sequence really matters. This is AAS. Decide whether triangles are congruent. So if we have to decide if they're congruent, if so, state the postulate or the theorem that we would use. So in this case, what's given is one set of angles. Angle E and angle J are matching angles, and they're congruent. I also know, for simplicity's sake, I'm going to say angle 1 and angle 2 are congruent because they are vertical angle theorem, right? And then EF is congruent to HJ, and that's given. That's given. This information is given as well. And so do I have AAS or ASA? Let's see. I go from here, AAS. So by AAS, you can write it this way, congruence theorem. Triangle, again, be careful. You can go from 1, 2 to 0. So E, G, F. F is congruent to triangle. I went from E, so I have to go from J, G, H. Okay, number 2, I'll use blue. In this case, what's given is, always start with what's given. MP is congruent to NQ. I also know MP is congruent to MP, right? Reflective, that has to equal to itself. Then that's it. There's no more information about the other side, and there's no information about angles. So I just say not enough info. Third one, I have, let's see. I have this parallels this, this parallels this. What does that give me? This is a little tricky. So let's look at it this way. I'm going to look at these two parallel lines. UZ, because UZ is parallel to WX, and my WZ is my, what is it called? Transversal. And therefore, I can say angle 1 and angle 3 are congruent because they are alternate interior angles, right? Alternate interior angle congruence theorem says if two lines are parallel, my alternate interior angles, remember alternating around the transversal, they are congruent. So that's one set of angles I found. That's an angle I found. Now, see if I can find another angle here. What about 2 and 4? If I look at UW is parallel to ZX. And if it's not easy, you can turn your paper around. You will see that angle 2 and angle 4 are congruent for the same reason. They're also alternate interior angles. I really didn't do a great job with these. There we go. That's a little better, right? 2 and 4 are congruent. So now this is my second set of angle, right? And then I also know that WZ is congruent to WZ, reflective property. We always are congruent to ourselves. So I have two angles and a side. And then let's look at the sequence. I have the side being sandwiched between the two angles. So this is an ASA congruence statement. So these two triangles, then you write out the by ASA congruence theorem, triangle, be careful with your sequence, WUZ is congruent because W is blue. I have to go for Z on the other side. U is nothing, so that's corresponding to X, and then W next. That's my final answer there. Here, this is exactly the same thing, but this time we're asked to state reasons. For proofs, it's really hard. I'm going to try not to include it in the exams, but you should be able to follow where your lecture is. Okay? Use the information to prove that two triangles are congruent. So for two-column proofs, we always start with what's given. BD and BC are congruent. Change the color. BD is here, right? BC is here. These two are congruent, and that's given. You always start with what's given. So that's given. What else is given? AD and EC are parallel. So AD and EC are parallel. If they parallel, notice I have two lines that intersect them, which means these two are transversals. If they're transversals, I can pretty much look for my four sets of angles. Angle A and angle E would be alternate interior angles, and they would be congruent. And same thing with angle D with angle C. They're also alternate interior angles, and they would be congruent, right? They're just cut out by two different transversals. So over here, they chose angle D and angle C. So we said this is alternate interior angles theorem. They have angles there. Alternate interiors angles theorem, which this one says if two lines are parallel, their alternate interior angles are congruent. That's our reason. And angle ADB is congruent to ABD, I'm sorry. So now they're using these two are congruent because they are vertical angles. Vertical angle theorem states that vertical angles are congruent. So look, now we have one set of angles, second set of angles, and do we have a line? We have a line. We have a side. So now let's look at this sequence. I have one angle, side, and angle. So therefore I can draw the conclusion by angle, right? ASA, congruence theorem. I can state that triangle ABD is congruent to triangle EBC. That's the reason. These are follow-up questions. Make sure that you complete those. And then that's it for this unit. Good job, guys.